straight out of Edison.
Ooh, straight out of World of Inquiry.
Yeah.
Boom.
And you're here too. We're hitting up our third lecture video in physical behavior matter.
3. It's like this.
3, if you're German.
Yeah.
Fine.
Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Anyways. Hey. This lesson was how to count.
Oh, yeah.
Yeah,
No.
We're going to hit up the types of energy and what they look like and all the definitions.
For us. So
Yeah, and
kinetic
some
energy.
temperature conversions too.
This looks better for kinetic energy, not like a roller coaster like we did before in the vocab.
Mhm.
This is what we're talking about in chemistry right now.
How fast are my molecules moving?
Yeah, and they moving, and moving is the key for kinetic.
Yeah.
Right?
Heat is the energy that causes molecules to move. Energy is of motion. Okay, so add heat, molecules move more. Take away
Right.
heat, molecules move less.
Right. Notice how it's all in caps, though, because heat is energy.
Temperature is not energy.
No.
It's an indirect measurement
Of heat.
Of heat energy causing things to move.
Right.
Which is really weird because you always think, you stick
You
a
think it's
thermometer
the
in
same
it and
thing.
it says 75 degrees. It's
But
how
what
much
is
heat
that?
it's got.
That's what.
No, it's related through a couple different steps.
Yes.
Heat causes atoms to move. Atoms hit the thermometer, causing the thermometer to move. The liquid expands and it goes
Right.
up. Oof.
Right. We got 3 kinds of kinetic energy that we deal with in, really calculus version chemistry.
Yep.
The first one you don't know, second one you do, third one.
This
you
is a
don't know.
lot more like geometry. So
It is a
like
little
they're
bit.
translational, vibrational,
So
rotation.
vibrational looks like this. It's the molecules are vibrating. When I told you the desk was moving, even though you don't see it moving, it's because I know it has some measure of heat. It's not at absolute zero, so there must be some sort of vibrational movement of the molecule.
In a solid, the molecules and atoms are moving in place, vibrating.
Vibrate. This is what we know about translational.
Right. In
Go
geometry,
from one class
yeah.
to another. Translate through the origin.
Right, or whatever it may be.
Right, that kind of
This
stuff.
is movement of physically one atom from its physical one location to wherever it might
Right,
be
which
later.
we just saw in that GIF. They were all moving all around.
And
That's
this really
translation.
only happens with liquids and gases.
Really.
Because
And even
they
this
can.
too, because rotational can't happen in a solid either. Instead of vibrating, it literally rotates.
Right.
Now liquids can do that.
Liquids and
Because they
gases
can
can
roll.
do that as well.
They can roll, but solids really can't. They
No.
only have that vibrational level.
If the atoms in a solid could rotate around each other, they wouldn't hold their shape.
Right, they
In
would
a
be able to
solid,
move.
it would turn into a liquid.
Exactly right.
So there it is.
That's it. Really is.
Potential energy
But
is a lot simpler.
knowing those three things help understand the Kelvin scale and what absolute zero is. Is really what we're doing. Is trying to set that up. Okay. So here we go. Potential energy. Again, it's going to be energy of position, but in our case, it's a little bit more stored up chemical energy.
So as that little guy goes up the hill and his potential energy increases, he's going slower. He's storing energy in his weight and gravity. And if nothing stopped him, he'd slide back down. It would get translated into kinetic energy again.
Correct.
So as kinetic energy goes up, potential energy goes down, and
Yes.
vice versa. Think of a
I
spring.
like this definition better than the one we gave for potential energy.
In
Maybe
the-
I'll throw you a curveball and put this definition on the quiz.
Energy of position or stored energy. For us, it relates to phase change.
I might put that on the
Truth.
quiz. I might
Truth.
put that on the quiz instead.
Truth.
Just so you know.
Just so you know. Heat versus temperature. Why aren't they the same, mister?
Because heat is the actual energy.
Yes.
Heat is it's the energy to burn you.
If you did a Google search on what are the different types of energy, you're not going to see temperature listed.
Ever.
Ever.
Come up with
They'll say heat.
Temperature is specifically the measure of that average kinetic energy.
If you want to look at the GIF and think about it like this, as that atom rotates harder and harder, it's moving faster and faster, it has higher kinetic energy. It transfers from high to low. So if a thermometer bulb was there, that heat would hit the thermometer bulb, and the thermometer bulb's atoms would start to move faster and faster, and they would expand because that's what they do. And the liquid in the thermometer would go up the little channel and give us a number saying, oh, this is 37 degrees Celsius. But it doesn't mean that's how much heat it has.
No, that's a whole different calculation, actually. When we do the calculations of heat, then you're going to understand. It's the heat of the whole system, not the temperature. So we're going to get there.
So typically in physical systems, heat always flows.
Yeah, there's no way to make it go the other way. Because literally, cold really is absence of heat.
Right, and heat is
energy.
So
cold is just absence of energy. Like if he's colder than me and I'm warmer, the heat's going to go from his hand to my hand.
Wrong.
Or no, right. He's cold, I'm warm, so heat goes from my hand to his hand. He feels my warmth, my energy,
and he feels my cold,
which is my energy leaving.
It's
I don't
really
feel
designed.
his energy coming to me. I feel my energy leaving in forms of heat and makes me feel cold.
Which is
But
why
it's really
we
just absence of
think
heat.
A lot of us have the misconception that cold is a thing.
It's not.
It's just the lack of heat.
Yeah, it's and
absence.
you know what's a great analogy is black and white, because white is all color and black is technically not a color. Black is absence of color,
Right.
right? And then
Absorption of all the wavelengths.
right,
It's absence of reflection.
absence of reflection. Right.
So, anyways, when you're holding the refrigerator door open, trying to figure out, you're letting all the cold out. No, you're actually letting all the heat in.
Which is it works out the same way. You know,
It really does.
You think about it.
We
So,
love arguing semantics.
yes, absolute theory or absolute zero theory.
So this is the temperature we think at which all atomic motion stops.
yes,
No
theoretically, we can get
vibrational, no translational, no rotational.
Right.
Atoms just stop moving.
there. Right. The last I checked, we were within 0.4 degrees Celsius of reaching it. So in the lab,
Oh, we're
we've
within
gotten.
billionths of a
Oh,
degree.
really?
Oh,
It's
yeah.
gotten even better.
Oh, billionths of a degree. Almost there.
Almost.
Almost there.
We're actually kind of concerned if we get there because we don't know what's going to happen.
Not
But
in
we'll
this.
see.
Not in this lab.
No.
Advanced research
No.
institutions at universities.
But the real
and
reason
colleges.
why this is important is because this talks about the Q equations and heat, like all heat, where the Celsius thermometer, we like it, but that is literally just the fixed points of water,
Right.
freezing and boiling points of water. That's the Celsius scale. That doesn't talk about all internal energy.
The Kelvin scale is a more true scale because it actually relates the motion of atoms to a value, a number of temperature.
Yeah,
At 0 Kelvin, ain't nothing moving around.
right. So it has zero energy.
And there's no upper limit to the Kelvin temperature.
Correct.
Like atoms just move more, faster, harder, further.
Because it isn't based on actual a specific substance like Celsius.
We think there's a lower bound. We haven't achieved it yet. That's why it's a theory. But we know so far that there's no upper bound to temperature either.
Right.
Temperature and kinetic energy.
Well, again, for the 13th time,
Yep.
heat is energy, specifically the kinetic kind.
Mm-hmm.
I mean, it's really important to understand that heat is energy.
Yes.
I think we said it like 8 times in this video.
We should keep track. We'll look back and maybe that's a question.
Oh, dang it.
How many times did Mr. Milk say heat?
is energy.
Is
specifically.
energy.
And so there you go. So go ahead, say it.
And temperature is the measure of average kinetic energy. So the average of how quick the atoms are moving, bumping into my thermometer, causes the temperature number to go
Yeah.
up to some value that we've decided is important.
But the key there is the verb. It's just a measure of it.
Yeah.
So it's not actually it.
Some conversions, because
Oh, yeah, let's do
we
these.
got to do some conversions in order
Me,
to
the
get
board?
there. Yeah, hit up the Celsius to Kelvin. So when we're doing a temperature conversion, just like any math, do the whole equation. Don't jump and skip steps. Everybody screws up when they do that. You might think that's not going to happen to me. Well, you know what? It's okay to do it from scratch. Yeah. So Mr. Milk started with the equation. He plugged all the variables he needed into, and he figured out that's it. If he's given 100 Celsius, he's got to say Kelvin equals something, 100 Celsius, plus 273. There we go. He knows how to do math, 373. Okay? Simple enough. The last one, negative 273. Don't panic. It's just a negative sign. He's just going to put negative 273 plus 273. So negative 273 Celsius equals 0 Kelvin.
0.
Yeah.
No degrees.
Now, going backwards the other way, you just got to plug them in and solve it proper.
Right,
So this time, instead of saying K equals value plus
I'm gonna say
273, 273 equals Celsius plus 273. Subtract from both sides to get Celsius by itself, and there you go. Last one, straight up plug and chug. He's going to say 373 Kelvin equals Celsius plus 273. He's going to take 273 away from both sides, and he finds out that this value is really 100 degrees Celsius.
Bam.
Okay. The Kelvin scale can be confusing, but it's really just offset from Celsius by 273 degrees.
Oh, it is.
Any
We're gonna find
value-
that the staircase is actually right in line.
And,
It's literally
and
just
the
shifted.
size of each degree is the same size too. That's
awesome.
really, really important.
Really important.
Comprehension question on my homework at least.
Yes. Hopefully on mine too.
2 pages of practice.
Let's see you go and try before class, and
Yeah.
otherwise we'll see you tomorrow.
I want to see you do it.
Peace out, Bean Sprout.
Bye. Nice. Peace out, bean sprout. You nerd.